So hello everybody. So today we are going to see the fifth unit in embedded system. I strongly recommend all to use your headphones or headset for the better audio and for the better listening. Okay. Okay, we'll go straightly into the fifth unit. So this is the portion or syllabus of the fifth unit. So here what we are going to learn is we are going to learn the history of the OS, and we are going to learn some of the important concepts like scheduler objects and important characteristics of this real-time operating system. So this fifth unit wholly covers the real-time operating system. So how this operating system, the real-time operating system, differs from the normal, that is general purpose operating system, and what are the similarities, and next how it's do its work, and how it's get communicated, and how the works are get concurrently processed, and what is the use of the semaphore in this real-time operating system, and what are the operation. Next we are going to define the message queue and its operation and its uses. Okay, fine. So what is mean by a real-time operating system? It's nothing but is a key to many embedded system today and provides a software platform upon which to build applications. So here we are having an operating system. So that operating system that is differs from the general purpose operating system. Okay. So this provides a platform. This provides a way to build a lot of applications. Okay, for the embedded system. So embedded system is a special, it is a special system, so that was used for a particular purpose. Okay, so applications can be built from a digital watch to navigating an aircraft automatically can be possible by using this RTOS. Okay, fine. So before going to see the RTOS, everybody should know what is meant by a general purpose operating system. So as a computer science students, you should know what is meant by an operating system is. So everybody know what is meant by an operating system. So Unix and Microsoft Windows are the most commonly used general purpose operating system. So Unix was used in 1960s and 1970s. Okay, so அப்போ பார்த்தீங்கன்னா, so Unix வந்து மிட் சைஸ்ட் அண்ட் மெயின் ஃப்ரேம் கம்ப்யூட்டர்ஸ்க்கு எல்லாத்துக்குமே என்ன பண்ணியிருக்காங்க அப்படின்னா யூஸ் பண்ணியிருக்கிறாங்க. ஸோ அது வந்து 1960s 1970s வந்து அது ரொம்ப பாப்புலராக இருந்திருக்கு. ஓகேவா. நெக்ஸ்ட் 1980s மைக்ரோசாஃப்ட் என்ன பண்ணுறாங்கன்னா தே இன்ட்ரடியூஸ் த விண்டோஸ் ஆப்ரேட்டிங் சிஸ்டம், அண்ட் இட் இஸ் மெயின்லி ஃபோக்கஸிங் த ரெசிடென்ஷியல் அண்ட் பிஸ்னஸ் யூசர்ஸ். ஓகே, so this Microsoft Windows operating system that made an revolution, okay, a revolution change in the personal computing era. That is personal computers வந்து அதிகமா யூஸ் பண்ண ஆரம்பிச்சது வந்து எப்ப அப்படின்னா after the introduction of this Microsoft Windows operating system. Okay, so this is a slight brief history. The next one is a similarity between the RTOS and GPUs. So the first similarity is the multitasking. So both can do the multitasking. Second, so both can do the hardware and the software resource management. Okay. Then both can uh, execute, or it provides a platform for different types of services to the application. Okay, it provides a platform, or it provides a what, a base for executing or what providing different services to application. So the application needs anything from the operating system, it can provide. Okay. Then abstracting the hardware from the software application. So the operating system making sure the software application does not care about, so it does not worry about the what type of hardware it is going to uh, work. Okay. So the abstraction or the hiding the hardware from the software application, so both the RTOS and the general purpose operating system will do it. Okay. Next, we see the difference between the RTOS and the GPOS. Okay. So better reliability in embedded system application context. Okay. So you need a lot of reliability, so definitely an RTOS will have a lot of reliability. Okay. Next, ability to scale up or down to meet the application need. So the RTOS should have this characteristics of scaling up. That means scaling up means what? It can grow, or down means it can shrink itself to meet out the application. Next, faster performance. Okay. So really you need in RTOS you need faster performance. So the difference, so reduced memory requirement. So when you compare to the general purpose operating system, you have a reduced memory requirement in the RTOS. Okay. Next, scheduling policies tailored for real-time embedded system. See, we cannot have the same scheduling policies as we applied in the GPU. So we have some special type of tailored or what a fitting type of scheduling policies are applied for the RTOS. Okay. Next, support for diskless embedded system by allowing executable to run, so to boot and run from a ROM or RAM. Okay. So I already told it's a memory constrained one. So memory in the RTOS are very carefully used and they are very carefully managed. So better portability to different hardware platforms. So this is one. So portability is one of the main thing, is one of the main difference between the RTOS and the GPOS. And you have to create the RTOS in a such a way to adapt the different hardware platform it takes. Okay, so these are the difference between the RTOS and the GPOS. Next, so this is the uh, technical uh, definition of the RTOS. So it's a program that schedules execution in a timely manner. It manages system resources and provides a constant foundation for developing application code. So the first work of the RTOS, it has to schedule, it has to manage, and it has to provide. Okay. So scheduling the execution, manage the system resource, and provides a consistent foundation for developing application code. So the developers has to uh, make this RTOS as a platform for applying different types of application code to the RTOS. Okay, fine. So this diagram will explain how this RTOS work. Okay, so this is the application. So you know what is mean by an application is. So this application is only view to the what the user or a person who are using the device will only see this application part. So this is the what, the application part, and this is the application. So this is the RTOS. The RTOS is the real-time operating system which runs on the embedded system. So it having all other components like network protocol, file systems, IO, debugging facilities, and device drivers. And then after this RTOS, you having one layer, that is the BSP. So it's nothing but is a board support package. So it's nothing but a software layer contains the hardware specific drivers and other routines allow to the OS to operate. Okay, so in between the hardware you are having this board support package, that is BSP. So when you take an embedded system with RTOS, it having one application layer, then you're having this OS. So between this OS, between this RTOS and the hardware, you are having one BSP. Okay. Next, scheduler. So scheduler is one of the main important object in the RTOS. Okay. See, in RTOS, we will view everything as an object. Okay. So that is the main important thing in the RTOS. Okay. So everything, uh, like scheduler and what a mutex semaphore events, everything. So everything will consider as an object. Okay. So RTOS having the kernel, which is a core supervisor software that provides the minimal logic, scheduling, and resource management algorithm. Okay. ஸோ அப்போ வந்து என்னன்னா எல்லாமே ஆர்டிஓஎஸ் கர்னல்குள்ள தான் இருக்கும். ஓகேவா? ஸோ இப்போ இந்த ஆர்டிஓஎஸ் இட் ஆல்சோ ஹேவ் த ஃபைல் சிஸ்டம்ஸ், இட் ஆல்சோ ஹேவ் த ப்ரோட்டோகால் ஸ்டாக்ஸ் அண்ட் அதர் காம்பனன்ட்ஸ் ரெக்வயர்ட் டு பர்டிகுலர் அப்ளிகேஷன். அப்போ ஒரு அப்ளிகேஷனுக்கு தேவையான எல்லாத்தையுமே வந்து என்ன ப்ரொவைட் பண்ணும் அப்படின்னா அந்த ஆர்டிஓஎஸ் கர்னல். ஓகேவா? கர்னல்லாம் நல்லா பண்ணுங்க. ஸோ அந்த கர்னல் தான் வந்து என்ன பண்ணும் அப்படின்னா it is nothing, it's nothing but what, it's a superior or it's a supervisor software. Okay, so which contains these components. Fine. So scheduler, so what is meant by a scheduler? Okay. So the scheduler is at the heart of every kernel. Okay. So அப்ப நான் ஏற்கனவே சொன்னேன் ஒரு கர்னல்னா வந்து என்னன்னா it is a superior software. ஓகேவா? that manages all the thing. So like that, அப்போ ஒரு scheduler ஒரு kernel குள்ள என்ன இருக்கு அப்படின்னா you have the scheduler. Scheduler is at the heart of the every kernel. So schedulable entities, multitasking, context switching, dispatcher, and scheduling algorithm. So scheduler contain each kernel and follows a set of algorithm and determine which task has to be executed. அப்ப எந்தெந்த டாஸ்க் செய்யணும், அதை எப்படி எப்படி செய்யணும் அப்படின்றது தான் வந்து என்னன்னா ஷெடியூலர் வந்து இது பண்றாங்க. ஓகேவா? ஸோ யூ ஜஸ்ட் see this kernel objects. ஓகேவா? ஸோ இப்போ இந்த kernel object அப்படின்னு பார்த்தீங்க அப்படின்னா ஸோ kernel objects that is a schedulable entities. ஓகேவா? schedulable entities அப்படின்னாலே எதெல்லாம் நம்மளால வந்து ஒரு ஷெடியூல் பண்ண முடியும். ஓகேவா? ஸோ அதுதான் வந்து என்ன பண்ற சொல்றாங்க அப்படின்னா schedulable entities அப்படின்னு சொல்றாங்க. சரியா? ஸோ அதில் பார்த்தீங்க அப்படின்னா ஆப்ஜெக்ட்ஸ். ஓகேவா? ஆப்ஜெக்ட்ஸ் ஆர் நத்திங் பட் எ ஸ்பெஷல் கர்னல். ஸோ அப்ளிகேஷனை வந்து நம்ம வந்து கிரியேட் பண்ணுறதுக்கும் அதை யூஸ் பண்ணுறதுக்கும் நம்ம என்ன பண்ணுறாங்கன்னா இந்த ஸ்பெஷல் கர்னலை யூஸ் பண்ணுறாங்க. ஆப்ஜெக்ட்ஸ் அந்த ஸ்பெஷல் கர்னலை யூஸ் பண்ணுறாங்க. ஸோ தட் கேன் பி அ டாஸ்க் semaphore or a message queue. Okay, fine.